you guys, let's go ahead and flip to page 40 in our notes. This is, and mine say section 3.4, but really this is section 3.3, and it is called Proving Lines Parallel. And I'm just going to guess that y'all's notes don't say that as well. So if you want to go ahead and change that, this is section 3.3, Proving Lines Parallel. Okay, I hope y'all's homework went okay, identifying the different types of angle pair relationships. Remember we have, and I'll look at our little transversal page again. A transversal, remember, is a line that just crosses at least two lines. And we have four angle pair relationships that are new to us. Our old ones are in one particular pod, you have sets of vertical angles which are across each other. Remember, those are congruent. And we have sets of linear pairs which are next to each other that form 180 degrees, so they would add to equal 180. Yesterday's new pairs were relationships that formed between two different intersections along the transversal. So we could have corresponding angles, which remember were in the same position. If this was upper left, then we had another upper left angle in that second pod. Those would be considered corresponding. We had alternate interior, which means they were on opposite sides of L, the transversal in this case, so something on the left and on the right that was between our parallel lines. So we could say that the squared angles are on opposite sides of our transversal, but still between in the interior of A and B. We had alternate exterior angles. Let's say the star is outside of line A, so we want something outside of line B, but on the left side of the transversal, so that could be that angle pair. We had consecutive interior. Consecutive interior meant same side of the transversal and both between the lines. So this could be like that square and our little squiggle here. Those are same side between A and B. We also talked about the relationships between those angles. If we had parallel lines, remember that was denoted by the bolded arrows. If those lines were parallel that our transversal was crossing, then we knew that corresponding alternate interior and alternate exterior angles were all congruent to each other. So if I had a pair of corresponding, I could set them equal. If I had a pair of alternate interior, I could set them equal. If I had a pair of alternate exterior, I could set them equal. The only one that was oddball out was consecutive interior, and those would be adding to equal 180 degrees. Those are supplementary angles. Okay, so new stuff for today is essentially the converse, remember, of our theorems from yesterday. So yesterday we said if our lines are parallel, that meant I had to look to see if my lines were parallel first, then I can conclude that they're going to be congruent or supplementary. Well, today's theorems, we're going to flip them around. So this time we'd say, oh, well, if my angles are congruent or supplementary, then I can say my lines are parallel. And if I know they're parallel, I can assume other things in solving from there on out. So let's go through these theorems. If two lines are cut by a transversal so that we end up with corresponding angles congruent, then I can say the lines are parallel. And we've said that here. On mine it's super tiny, so I'm going to rewrite it. The lines that are parallel are the ones that are being crossed by your transversal that form the angles they're talking about. Okay, so in this case I would say J is parallel to K. That's what I can conclude if my angles are congruent. Alright, same thing. If you have two lines that are cut by your transversal, we'll call that T, to where your alternate interior angles are congruent, then the lines are again parallel. So I would say J is parallel to K. We have another theorem. Hello? Yeah, are you here? Yeah, where are you coming from? Off to your Colony. Okay. Um, so I think you go straight on Cedars Colony across Old Settlers, and then you'll turn left. You'll see like a big parking lot, a student parking lot. Turn left there, and like where you see where the construction kind of meets the like that first main entrance you see in the gym parking lot. That's where you'll park. What car are you in? Oh, Papa John. Okay. Yeah. I'll send somebody out there to find you. Okay, thanks. Bye. Sorry, y'all. Apparently, our pizza is here. This is what you do when you stay at the school late. You order pizza. Okay, so we have continuing theorems that are going to be just like um, the other ones, except for each different angle. And the relationship is you want congruent angles for all of them except for consecutive interior. All right, so alternate exterior angles. If we have lines cut by a transversal and our pair of alternate exteriors are congruent, then I can conclude the lines are parallel. So I could say J is parallel to K. If two lines are cut by a transversal so that your consecutive interiors are supplementary, then the lines are parallel. That's exactly what we want. So again, we conclude J is parallel to K. I know these theorems are kind of redundant in that their conclusion is the same. The part that is different is the hypothesis, what kind of angles you have and what kind of relationship they are. So for example, if we look to the right here, we have these lines where I would consider this the transversal. We'll call that T. And I want to find the value of x that makes those lines A and B parallel. Well, remember, I need to look to see what I want their relationship to be. So I have to identify their relationship based off of the transversal. So I'm thinking, okay, the lines are on the same side of T, or sorry, the angles are on the same side of T. One's between the lines, one's outside. So right now I've automatically eliminated any alternate things because they're on the same side. They're not consecutive interior because they're not both between the lines. So my only other alternative is corresponding. So I'm going to check in this particular pod, 5x minus 7 is considered the upper left to me. So I would ask myself, is 98 degrees considered upper left in that second pod? Which it is, so I know these are corresponding. Corresponding, if I can write that correctly. Okay, so if they're parallel, that means that these must be corresponding angles, have to be congruent. So I'm thinking, okay, if they're going to be parallel, these values need to be equal. So I know that 5x minus 7 would have to be equal to 98. Okay, so we would just solve this by adding 7 to both sides. Therefore, 5x would be equal to 105. And when you divide both sides by 5, you get x is a value of 21. Since that's all they asked for to find the value of x, you're done. Okay, so transitive property, let's go back down here and look. Just a little heads up, you always want to identify what type of angle you have first before you set up your equation. You cannot write an equation unless you know what type of angle pair you've got. And there will be several questions on like quizzes or tests that you have to identify the angle first, then set up the equation. All right, so look at this last theorem, theorem 3.7. And again, you don't have to know the name of this particular theorem, but I would be okay, like we'll use these theorems in our proofs. You could either call it the consecutive interior angle converse, or you can use the actual if-then statement, the conditional statement form of that theorem. And I'll show you in just a little bit how to abbreviate it down so it's more concise. All right, theorem 3.7, the transitive property of parallel lines. Remember, transitive property in general is the property that relates three things together, like if A is equal to B and B is equal to C. Since those are the same, I can just combine those into one statement and say that A is equal to C. The concept's the same. If you have two lines that are parallel to each other, or they're parallel to the same line, if P is parallel to Q, but R is also parallel to Q, that means that I'm looking at a row of parallel lines, so I could conclude that P is parallel to R. So you would say that they're parallel to each other. And this is how it is written out, and I can write that a little bit bigger for you to see. If P is parallel to Q, that's not a Q, and Q is parallel to R, then you can, just like we did here, if they're the same in the center, you can conclude across from beginning to end that P is parallel to R. Okay, so let's look at this side diagram. You're going to be able to be able to pick out which lines are parallel to each other depending on your angle pair. This theorem says, well, actually, this just question asks you to look at 2 and 3. So I'm going to highlight 2 and 3. If angle 2 is congruent to angle 3, then what can we conclude? Well, okay, there are several things you can conclude depending on what the question is asking you. I could conclude the type of angle relationship that these are. Okay, well, what line touches both of these angles? Because the line that touches or crosses both of these angles, that forms both of these angles, is going to be the transversal. So if I am guessing, and I want to say, oh, maybe X is the transversal. When I trace over X, you see how it's nowhere near 3? That means it's not the transversal. Same thing with B. B doesn't even touch by 2 or 3. Same thing with Y. It only touches 3. So if I trace A just went right by 2, and it went right by 3. So A is my transversal. And I would write that off to the side. A is the transversal. Because if you can identify that, that will help make your identifying which angle pair it is a lot easier. So in relation to our transversal A, 2 and 3 would be considered opposite sides. And if I check to see if they're between the lines or out of the lines, they are outside of the lines. So since they're opposite outside the line, that's an indication that these types of angles are alternate exterior. Are alternate exterior angles supposed to be congruent if we have parallel lines? Yes. The answer is yes. So they should be congruent, which they are. And if they're congruent, that means I have parallel lines in the picture, even though I don't see those bolded arrows. Because I know my angles are congruent, I can say, oh, my lines are parallel. Well, you have to know which ones are the parallel lines based off of angle 2 and angle 3. Well, your parallel lines are the ones that your transversal between those two angles is crossing. So it crosses over X and it crosses over Y. So that means I can conclude that X is parallel to Y. All right, let's flip the page. Let's go through these questions. Remember how I said that when you're writing proofs, you could either write the converse theorem or the corresponding angles theorem, or put it in if-then form? There are times when I would specify, I want you to write it in if-then form, the conditional statement form. If that's the case, these are going to help you figure out what to write. So we're on page 41, and we're going to use this figure to be specific in our conditional statements, because you can't just say if those angles are congruent, then the lines are parallel. You need to be very specific. If these lines are parallel, then those corresponding angles are congruent. You know what I mean? You have to name the angle pair relationship. You have to name the lines. Okay, so given is that A is parallel to B, and that's denoted by those bolded arrows. So I can also see that in the picture even if it wasn't given. And we want to prove that angle 1 is congruent to angle 3. Well, I'm going to use blue in this proof so you can kind of see. Angle 1 congruent to angle 3. All right. If this was given, so if A is parallel to B, then blank angles are congruent. Okay, I just have to identify what kind of angles I'm looking at. The transversal is the one that touches both, so this is going to be our transversal. We'll call that T. In relation to the transversal, angle 1 is in upper left, angle 3 is in upper left. They're in the same position, so those are corresponding angles. So the whole statement that you would write as your reason in the proof would be angle, if A is parallel to B, then corresponding angles are congruent. All right, look at the second one. A is parallel to B is given again, except this time, and I'll use a different color, we are looking at, I'm going to start those, these are orange. Angle 2 is congruent to angle 7. So I'm going to go up to my picture. Here's angle 2, here's angle 7. We're still looking at the same transversal, but in relation to the transversal here, we have a different angle pair relationship because they're not in the same position in each pod. So our statement will be, if my lines are parallel, if A is parallel to B, then what kind of angles are supposed to be congruent? Well, we've got to name the angle pair relationship. They're opposite sides of T, but they're still between my parallel lines. So these are going to be alternate interior angles. All right, look at statement 3. This one's a little bit more complex. There's more information in this proof. Again, we're given, here, let me zoom out since you can't actually see this. Okay, that zoomed really in. Sorry, y'all. Okay, let's look at the proof. I'm going to have to separate this a little bit. This is going to be green. Given our lines are still parallel, so I can conclude if my lines are parallel, if A is parallel to B, then this is where I check my angle pair relationship. I'm going to go look at my picture about 6 and 7. Here's 6 and here's 7. All right, do you agree they're on the same side of the transversal? I forget I'm talking to a video. Okay, you can't answer me. Yes, they are on the same side of the transversal, and 6 and 7 are also between the lines. So same side between the line would be considered consecutive interior. Please, please, please know the difference between corresponding and consecutive interior. Don't just remember the C part, because clearly they both start with a C. All right, keep going. If I can conclude that 6 and 7 are supplementary, then I can, according to the next step, say that their measures must add to equal 180. How would I go from a word to a measure of an angle? That must mean I know the definition of that vocab word. So go pick out the vocab word that you've said in that statement. It's supplementary. So this would be definition of supplementary. All right, keep in mind, these are just mini proofs. We're about to have to do a longer proof. All right, so we've got proving lines parallel. This time we have angle 6 and angle 8. I'm just going to go and eyeball the picture. Angle 6 and angle 8. 6 is in bottom right of the first pod. 8 is bottom right of the second pod. So these to me are going to be corresponding. The difference here is that we've started with those angle pair relationships being congruent. If your corresponding angles are congruent, then your lines are parallel. So these are proving the converse of whatever our original statement was. So if those corresponding angles are congruent, then the lines are parallel. If you just say if angles are congruent, it would be wrong. You need to make sure you're specific about the angle pair. All right, this time we're looking at 3 and 6 on the next one. Angle 3, angle 6. Those are opposite sides of T, the transversal, but they're still between the lines. So these are going to be alternate interior angles. If I have congruent alternate interior angles, keep in mind you have to specify if it's interior or exterior, don't just say alternate. Then you can prove your lines parallel. All right, let's do some actual proofs with this so you can see what I'm kind of talking about. Remember when we hit the proofs the last week for the last unit, there were certain things that you had to kind of look for. Remember, we always start with a given. So we have our given, then we have our define. You have to define your vocab, those kind of things. And from each step on, your next steps either came from a previous step or they came from your picture. Okay? So you're going to have to be able to identify both things. Same kind of concept in these proofs. So given A is parallel to B, which I also see in my picture from the bolded arrows, we need to prove angle 5 is congruent to angle 4. Angle 5 and 4 directly are not one of the angle pair relationships. Actually, that's not true. They are. What am I saying? Okay, they are alternate exterior angle pairs, but what this theorem is doing is it's proving the fact that we have alternate exterior angles. So it's broken it down a lot more than what you could do in your own proof. This is just giving you the idea of a proof. So we have A is parallel to B, that was given. They're going to say as their next step that 5 is congruent to 7. Why is 5 congruent to 7? Well, this is the fact that if I have A parallel to B, then I can conclude that because those are corresponding angles, then I can say corresponding angles are congruent. Oh, let me zoom out a little bit. There you go. If A is parallel to B, then corresponding angles are congruent. Okay? It was specific. I named the angle pair, and I named the lines that were parallel. Look at the next step. Angle 7 is congruent to angle 4. I have mentioned angle 7 in the step above, but we haven't talked about angle 4 yet. That means it didn't come from the steps above, it came from the picture. If I look at 7 and 4, those are in the exact same pod, and remember the relationships we have formed by an X? These are opposite of each other, so I would say, what kind of angles are those? Those are vertical angles. So because I know they're vertical angles, and that the vertical angles theorem says those vertical angles are congruent, I can say 7 is congruent to 4. Look at step D. It's combining angle 5, which came from step 2, and angle 4, which came from step 3. So we've taken these two steps and consolidated it into one step. So this consolidation of equations either comes from substitution or transitive. And remember, substitution has addition and subtraction along with those equations. Substitution you cannot use with congruent signs. So this has to be the transitive property. And I know that because I'm comparing 1, 2, angle 7 again is a second thing, and then angle 4 is your third thing. So transitive property uses 3 different things. So you're done. All right, look at the next proof. Angle 1 and 4 are supplementary. Angle 1 and 4 are supplementary. That's given, which is good because they're not a direct angle pair relationship that I know yet. And I want to prove that my lines are parallel. Keep in mind, these bolded arrows should not actually be there because I don't see in my picture that the lines are parallel yet. I shouldn't because that's my goal to prove that. All right, angle 1 and angle 4 are supplementary. I know that because it's given. They told me to start there. Part B, angle 1 and angle 4 equal 180. What word reminds me of 180? I'm thinking to myself, oh, that's supplementary. And if I look, the word supplementary was in my given. So I've defined that word. That tells me that this is definition of supplementary. Look at the next one. The measure of angle 3 plus the measure of angle 4 equals 180. Have I talked about 3 yet? No. I keep asking questions. I feel ridiculous. Sorry, y'all. I'm asking questions to myself. Okay, so angle 3 has not been mentioned, which means that comment or that equation came from the picture. Look at 3 and 4 in your picture. They're in the same pod, which tells me this is some old relationship between those two angles. Do you see how they're a linear pair? I know those are a linear pair, which tells me I can say they add up to 180. So this would be just linear pair. And I don't care if you call it a theorem or a postulate. I care that you know that it's a linear pair. So I'm not going to be picky. Make sure you put something though. Don't just put linear pair. Linear pair theorem, linear pair postulate, perfect. All right, step D. Measure of angle 1 plus angle 4, which that looks like a lot like step B, is equal to the measure of angle 3 plus the measure of angle 4, which looks a lot like part C. That means we've taken these two steps, consolidated into one. Anytime you're combining steps, it's probably going to be substitution or substitution or transitive, which, since I have these addition signs, it cannot be transitive property, so that tells me this is substitution. The more proofs y'all do, the more you'll be able to identify these like key elements that help you kind of get through these proofs quicker. Step E, measure of angle 4 equals the measure of angle 4. What? That sounds silly to name. If it sounds silly and totally random, odds are good it's probably something that didn't come from above steps, didn't come from the picture. It's something you're just going to have to be able to pick out immediately. You have something equal to itself. I'm thinking reflection. So this is reminding me that that's reflexive. Step E, angle 1 is equal to angle 3. The last time I saw 1 related to angle 3 was in step D. So I'm asking myself, okay, what changed from D to F? I've eliminated the angle 4s from both sides. If I was going to get rid of angle 4 on both sides, I need to subtract those out. So this would be the subtraction property. Then all of a sudden we go to parallel lines. Okay, this would be a converse of something. I need to go look at 1 and 3. 1 and 3 are what kind of angle pair? That's what you need to identify. They're on the same side. They're both upper left in their pod, which tells me they are corresponding angles. So this would be the statement. If corresponding angles are congruent, then you can say your lines are parallel. A is parallel to B, which is what our step is. That's how I prove that. All right, y'all flip to, tonight for homework, you're going to have your own proof. Go back and look at these types of problems to help you reason through. See if it helps you. I really want you to try those proofs on your own because you'll turn those in tomorrow. All right, let's flip to section 3.6, which is page 50. And let's really quickly go through these theorems. These are things that are common sense to me. I feel like they would be common sense to you. They just have, there's just names that go with them. And now they've been put into conditional statements, so in if-then form. Angle 1 is congruent to angle 2. If those two are congruent, do you know how these are also a linear pair? So that means that angle 1 and angle 2 have to add to equal 180. Well, if they share that evenly in two ways, they must equal 180 divided by 2 is 90 degrees. Well, if those angles are 90 degrees, can't you say those lines are perpendicular? So you can conclude that A is perpendicular to B. And remember that upside down T means perpendicular. You will see that symbol a ton along with parallel. All right, our first theorem. If two lines intersect to form a pair of congruent angles, like the problem we just worked, then the lines are perpendicular. And you can say G is perpendicular to H. All right, theorem 3.9. If two lines are perpendicular, then they form four right angles. This is basically the converse of theorem 3.8. So I could say angle 1, angle 2, angle 3, and angle 4 are all right angles. All right, theorem 3.10. If two sides of two adjacent angles are acute angles, two acute adjacent angles are perpendicular, then the angles are, this would be complementary. Just saying, if you have two perpendicular lines, the angles that it's forming are going to be complementary. So you would say in this picture, angle 1 and angle 2 are complementary. Theorem 3.11 just says if you have a transversal that's crossing two parallel lines, and you know that it's perpendicular to the first, since the lines are parallel, it's going to be perpendicular to the second. So in this picture, I could say J and K are perpendicular to each other. The last one, same concept. If you have two lines that are perpendicular to the same line, in this case P, then they must be parallel to each other. So you say M is parallel to N. This next question is something that you could expect to see maybe on your quiz, maybe on a test, something along those lines. You have to identify maybe a pair of parallel lines or perpendicular lines. So use our theorems. We have two lines perpendicular to the same line. So I could say X is parallel to Y. Same thing here. Two lines, X and Z, are perpendicular to S together, so they must also be parallel. X is parallel to Z. Go the different direction. Let's rewrite this. R and S are perpendicular to X, so they must be parallel to each other. Oops. R is parallel to S. And if you wanted to write underneath X and Y, they're both perpendicular to R. And then underneath X is parallel to Z, you could write that they're both perpendicular to S. R and S are both perpendicular to X. And let's see, am I missing one? We have R and S, we have X and Y, we have X and Z. From here, you can just use logic. The fact that R is already parallel to S, that means that just because this is a right angle, there's also one right here. So you could say that they're both perpendicular to Y, or parallel to Y. And Y is then parallel to Z. May not be true that all of your lines are parallel to each other, but you could have a lot that are in one picture. All right, let's do this next proof. Given angle 1 is congruent to angle 2, let's use one of the theorems we just talked about. If you have two congruent angles that form a linear pair, they must both be 90 degrees, therefore those lines are perpendicular. And that theorem is this statement on the previous page that if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. And you'd write that shorthand like this. So if angle 1 is congruent to angle 2, then G is perpendicular to H. So let's go ahead and put that on this one, because this one says our angles are congruent. So if angle 1 is congruent to angle 2, then our lines are perpendicular. So PS is perpendicular to PQ. And then we have angle QPS, this angle right here, and angle 1 are right angles. And that becomes because those angles are vertical. So this would be actually, I would just say that this is definition of right angles. All right. Okay, so distance between 2 points is always the distance that is shortest to those points, which is always going to be a straight line, and it will always be perpendicular to where you're traveling from. So go ahead and write in here that the distance between two parallel lines is just the distance along the line that is parallel or perpendicular to that. So in the diagram, M and N are parallel, so the shortest distance is going to be this distance where they're parallel. I'm sorry, perpendicular. Oh my goodness. Confusing the words up. Alright, look at the next page. Let's do some practice with determining these measures. Alright, 75 degrees and angle 1. They form a right angle, so that means that 75 plus whatever the measure of angle 1 is should total 90. So that means angle 1 would be 15 degrees. In this one, since you have one right angle, these two lines are perpendicular. That means that every angle is a right angle. So therefore, this 60 degrees is vertical to that angle, and that means that angle 1 and 60 degrees add to 90 degrees. So that means the measure of angle 1 would be 30. Same kind of concept here, 25 degrees and x plus 25. They form a right angle, so they're going to be complementary. This case, though, we don't have enough information, but we can say that 25 plus x plus 25 equals 90. Combine your like terms, so we have x plus 50 equals 90, and therefore x would be 40. It is not degrees, even though I almost wrote that, because x is not representing the angle in this picture. It represents the variable measure. Alright, y'all should be very good at this pinwheel type problem by now because we've tested over it for a couple of units now. Identify your congruent angles. For example, 65 forms an X with angle 6. Those are vertical angles, so this one's also 65. Since 6 and 5 both have congruent marks, that means angle 5 is also 65 degrees. What else can I say? Well, 65 over on the right with angle 3 add up to 90. So if I do 90 minus 65, I end up with 25 degrees for angle 3. Angle 1 and angle 3 are vertical angles, so those should be congruent. Another thing you can say is, since these lines are perpendicular, angle 2 and angle 38 add to 90. So if I subtract 38 from 90, we get 52 degrees for angle 2. And the same concept for 5 and 4. 4 and 5 add up to 90 degrees, so if I take that 65 degrees out, we are left with another 25 degrees for angle 4. Alright, we are looking at a partial map of a town that's drawn here, and HL is representing Main Street, CM represents 4th Avenue, point L represents the library, C is the center of town, H is the high school, and M is the medical center. We want to find the distance from the medical center to the high school. Okay, each of these markings, the axis is moving by 100, right? Every line. So this would be 1, 2, 3, 4, 5, 6, 700. So this would be 700 feet. Alright, so how far away is the medical center from the center of town? I want to calculate this distance. There are several ways you could find this. Because you don't necessarily know that these are perpendicular yet, as Part B asks us eventually, are they perpendicular? Um, we actually need to calculate distance. So I would find this ordered pair. M is at 900, 300. C is at 500, 600. So I need to plug that into the distance formula. So Cm is the square root of, remember, y2 minus y1, so 300 minus 600 squared, plus x2 minus x1, 900 minus 500 squared. So we'll simplify. Negative 300 in parentheses squared plus 400 squared. We'll simplify. That ends up giving us 90,000 less 160,000, excuse me. Simplify even further, we get this is the square root of 250,000, which ends up giving us 500. So this would be a 500-foot distance. We'll do the same thing for the next distance. It says, what distance do you walk if you go to the medical center? From the medical center to the library along 4th Avenue and Main Street. Well, 4th Avenue, remember, is this line. So we want the distance that we just calculated, that 500 feet, plus going on Main Street, we want to calculate the distance from C to L. So L is the ordered pair 700, 800. So we need to do distance formula again between those ordered pairs. So you could do y2 minus y1 over x2 minus x1. You end up getting 100 square root of 8. So I'll go Cm is 100 square root of 8. And if I add that to the 500 that we just got, that gives us approximately 780 feet. So we want to know, is 4th Avenue perpendicular to Main Street? Well, how would you calculate that? If it was perpendicular to Main Street, then we would want to know, hey, that might be a right triangle, right? So you could do Pythagorean theorem. It turns out that it's not. We just calculated that was 500. We already know HM is 700. You could do distance formula again between H and C, which would be 424 feet. So you would test out Pythagorean theorem. A squared plus B squared equals C squared. And in this case, we'd have 424 squared plus 500 squared equals 700 squared. And you're just guessing, is that going to make a true statement? Which in this case, it gives you 490,000 is equal to 429,776, which is not true, which is why they are not perpendicular. Okay, that's a very intense problem of distance. This problem is just to get you thinking, to understand, hey, can I find them perpendicular? Can I use distance formula on a graph? Okay, y'all's homework for tonight that you're going to finish in class, or you should finish in class, at least definitely get most of the way through. It's homework 15 plus the worksheet proof 1. Plus your proof worksheet, which your sub is going to hand out to you. Again, your quiz is tomorrow over identifying your angle pairs, deciding if they're congruent or supplementary, solving for x when they're congruent or supplementary, proving lines parallel, explaining why the lines are not parallel, why they are, and so forth. If you need tutoring, whatever, please come see Ms. McKeever, any of the other geometry teachers, actually any math teacher. I'll be back tomorrow morning. So I will be here tomorrow morning for tutoring if you want to come before school to get a little bit of help before we take our quiz. All right, good luck, y'all. See you tomorrow.